Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 6th grade topic, solving proportions with expressions. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always put them in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. This video will have 2 examples, so leave a like, smash the subscribe button, and let's get started. So before we can jump into our 2 examples for today, we need to talk about what an expression is. Now, previously in my last video, I talked about how to solve proportions. However, we focus only on those with single variables. In today's video, we're going to be tackling proportions with expressions. So it's going to be a little bit different. However, you have no idea how to even solve those with the single variables. I recommend you pause this video and go check out my video on how to solve them with the single variables, and then come back to this once you have a good understanding about how to do it. We're going to be doing the same exact steps, so I want to show you how what you know before is going to be very applicable to solving these type of proportions. So now that that's out the way, what is an expression? Well, if you remember, we talked about variables, and I told you that a variable can be pretty much anything. It's a placeholder. We don't know what that number is, but it's a placeholder for an unknown number. So it could be X, it could be Y, it could be A, it could be B. It doesn't matter what it is. It can be Greek letters. It does not matter. But these are variables. An expression has the form of number, and there's some math operation holding them together. This can be plus, minus, times, or division. It doesn't matter. There is going to be at least 2 numbers and some kind of math operation holding them together. That is what makes an expression. So let's use real numbers. So let's say we have 3 and 4. And let's say you want to add them together. This is an expression. Now you can solve this. If you put the equal sign, you'll see that that equals 7. And now you've turned your expression into an equation, but we don't need to go all that far. We're going to simply focus on expressions. This is an expression. You can do the same thing for another number. Let's say 7 minus 8. That's an expression. Let's say you have 2 times 9. That's an expression. Let's say you have 5 divided by 5. This is an expression. When you have at least 2 numbers and they're held together by a math operation, you have an expression. Now, expressions can be way bigger than this. These are very simple expressions, but remember, they have at least 2 numbers and at least 1 operation holding them together. So you see, in this video, we're going to be moving from something like this to something like this. Instead of solving with a simple variable in your proportion, we're going to now have an expression with an unknown in your proportion. So let's jump into our first example for today. So this is going to be our first example for today. 4 over m minus 8 equals 8 over 2. Now, you don't even need to do what we're going to do in just a moment. You can probably eyeball this and tell me what m equals in order for this to be true. However, let's do the steps just to make sure we know how to solve them in case you have a more complicated example. So if you remember in the first video, whenever you have your proportion written out like this in fraction form, you can just do your cross multiplication. And cross multiplication is going to tell you to focus on your diagonals, and you multiply them. So you're going to have 4 times 2, which you get here, and then you're going to have 8 times this thing here. This is our expression. So it's going to be m minus 8. So 4 times 2 gives us 8. So 8 equals 8 times m minus 8. And we want to get m by itself. Remember, that was the same thing we did in our last video. Get your variable by itself. You see, nothing is changing. You might have a little bit more work, but the process is still the same. So how do we get m by itself? Well, m is in these parentheses. They're kind of protected. You can kind of think of the parentheses as a barrier. You can't really do anything without removing everything outside the barrier first. So how do we get rid of everything outside of the barrier? Well, this is connected by multiplication, right? 8 times this parentheses. So we can divide both sides by 8 in order to get rid of this 8 on this side. 8 divided by 8 gives us 1, so you can put times 1, you don't necessarily need to. So I'm going to leave it out. We have an understood times 1. But whatever you do to one side, you have to do it to the other. We have to make sure that this stays equal. And 8 divided by 8, once again, we said gives us 1, right? But this time we want to write 1 because there's nothing else on this side. So 1 equals m minus 8. Now we lose the parentheses because we no longer have anything on the outside. But our goal is still the same. We need to get m by itself. What are we going to do in order to get m by itself? Well, now instead of having multiplication holding something together, we have a subtraction sign. So we're going to add. We're going to do the opposite. We did the opposite here. In order to get rid of multiplication, we divided. We're going to do the opposite here. In order to get rid of this subtraction, we have to add. So we're going to add 8 to both sides. Now, what do we get? Well, that cancels out, and this gives us 9. 9 equals m, or you can say m equals 9. So let's plug this in to make sure that this is truly our answer for this example. So we have 4 over 9 minus 8 equals 8 over 2. Now, 9 minus 8 gives us a 1. So this actually is going to be 4 over 1 equals 8 over 2. Now you can see that this is the same. However, let's just do our cross multiplication to make sure. We're going to just verify it. If you see this on a test, I'm pretty sure you can say with confidence your answer is correct. Don't waste the time, but hey, we have some time here. Let's kill it. So 4, remember, cross multiplication, looking at the diagonals. 4 times 2 equals 8 times 1. Is this true? 8 equals 8. Yes, this is true. So we know that our answer, m equals 9, makes this set of ratios, remember this is a proportion, this set of ratios equal to each other, thus makes them a proportion. Let's move on to our next example. So our second example is going to be 9 over k minus 7 equals 6 over k. Now I chose this example because in my last video I kind of misspoke a little bit. I said that out of the 4 different places you have here in your proportion, one of them is going to be an unknown and the other 3 are going to be given to you. However, you see here, that's not the case. What I actually meant to say, or should have said, was you're only going to have a maximum of one variable, one unknown variable. So you see, although we have 2 spots here with a quote unquote unknown, we only have one variable that's unknown to us. And that's going to be true for any kind of equation. So you might not necessarily need to know that right now, but whenever you have one equation, you can have a maximum of one unknown. And you see we have one equation here because there's only one equal sign. So this is a maximum of one unknown. So let's jump into some cross multiplication. So we have our diagonals here, and it's 9 times k equals 6 times, right, k minus 7. So in this case, remember we want to get k by itself. Nothing is changing. However, how we go about it is going to be a little different. Instead of getting 6 over here first, how about we distribute the 6? Because we want to ultimately get all the k's by itself. So let's get rid of all the parentheses and stuff that kind of keeps k isolated so we can easily manipulate and move things over when we need them. So instead of dividing both sides by this 6 like we would have done in the previous example, we want to distribute this 6 to both of these to remove the parentheses. That way we can get all the k's to one side very easily. So we have a 9k equals, because 9 times k, right, equals 6k minus 42. Now you can move things over in any which way you want. However, I'm going to focus on the 6k only because we already have 9k by itself and this side has a constant. So moving over too much can get very messy. Moving over one thing is going to be much simpler. Now I'm going to move over the 6k. And I do that by subtracting 6k from both sides. That cancels out, and I'm left with 3k, right? 9k minus 6k gives us a 3k equals negative 42. Don't forget your negative. The whole thing has to come down. So we have 3k equals negative 42. Remember, we want to get k by itself. That means we're going to have to divide both sides by 3. This is going to cancel out that 3, and we're going to be left with a k equals negative. Remember, your negative is here. And what's 42 divided by 3? Well, that's going to be 14. So our answer is k equals negative 14. So let's plug this negative 14 back in to make sure that we actually get something that equals. So that means we have 9 over 14, or negative 14 minus 7 equals 6 over negative 14. Well, what's negative 14 minus 7? Well, that's going to give us 9 over negative 21. And that's going to equal 6 over negative 14. Now you can verify this in a few different ways. However, we're just going to do cross multiplication because we want to keep things simple. So remember, you're going to focus on your diagonals. And you're going to get 9 times negative 14 equals 6 times negative 21. So what's 9 times a negative 14? Well, you're going to have your negative there. Never forget that negative. I can't stress that enough. 9 times a negative 14 gives us a negative 126. And that's going to equal 6 times negative 21. Once again, that negative is there. So 6 times negative 21 gives us a negative 126. And these two equal each other, so our proportion is set. This is truly a proportion, and k equaling negative 14 is truly our answer. So I hope you're able to follow into these examples, and I hope you see that as long as you know how to solve proportions, even with your variables, solving them with expressions is not going to be much different. You're going to use the same exact process, getting your variable by itself. However, you might just have a few extra steps. If you have any questions about what we saw today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already yet, remember, hit that like button. It really helps the channel because it lets YouTube know that you found this video helpful. And if you found it helpful, someone else can as well. So hit that like button, smash the subscribe button, and while you're at it, hit the notification bell so you know exactly when I drop my videos. P.S. Share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.